Patovka here to share a little bit experience about identification patterns of TV consumption. And I think that after a great workup session, we will have a fun to look at the data and to run some interesting algorithm on this data. And the previous speaker said to touch a little bit implementation stuff, some details, but it's up to you. If you have more details questions, I will be happy to answer them. We will run on this data, on our TV data, self-organized map algorithm. A couple of words before, it's unsupervised visualization technique that we will use to reduce our high-dimensional data to, in our case, two-dimensional data set. But first of all, I like to show you where actually data come from and what is at the beginning.
Can you feel it coming around? Entdeckte Welten, Universen des Wissens, neue Ufer, große Bühnen, große Stadien, großes Kino, kleine Wunder, spektakuläre Events, faszinierende Abenteuer. Was immer Ihr Herz höher schlagen lässt, wir bringen Sie hin.
Es geht los.
Sollten wir nicht nervös sein?
Ja.
Die Sehenswürdigkeiten des Frühjahrs 2017. Jetzt buchen. Eine bessere Chance kriegst du nicht. Willkommen an Bord der Seven One Media.
All the spots and video material running on our 7 TV channel. I go just quickly. Okay, 3 PV channel and about 40 digital platforms. We can imagine that a lot of different data, a lot of different video material, movies, a lot of people who watching these movies, and it's bring together really big amount of data, which we will try in the next 20 minutes a little bit to classify and in order to find patterns and some kind of behavior. Let's look like all data science project. We are starting from data sources. In our case, we have data sources from GFK panel. I'd like to share a little bit how it actually works. Whole Germany will be classified on a couple of 5,000 households and about 100,500 viewers. GFK get daily or each second information from each viewer, what he or she look, how long, which sender, and so on. It's like no cookies and no magic. We are getting this data officially from GFK, no spy, no hiding cameras. Exactly. It's a big challenge now to try to classify all this amount of data and try to find what is actually a common feature in viewer who prefer watch ARD, ZDF, who prefer watch RTL or Ziva. Let's look a little bit at genre classification. how it works. We can split genre or start from broadcast mode, from broadcast mode, and split it on fictional genre or non-fictional theme. Non-fictional theme could be split on the broadcast format and fictional theme. And for example, magazine, news magazine, politics in general, food and kitchen, and so on. It's everything what belong to non-fiction theme. And fictional genre, it's a little bit more funny. It's TV, movie, serials, movie USA, movie Germany. It means we already started a little bit to classify people or viewers who watching, for example, who like sitcom USA and watching, for example, politics in general. We have about 2 million records per day. It depends on accumulation level. Of course, we can accumulate data, but usually we can start from 1 minute's usage. And about 100 genre combination, because all of the genre universe could be combined, and people can watch, as I said before, TV, movie, and politics, and plus food and kitchen, and that everything generate actually a lot of genre combination. Just a quick look at distribution share broadcast format across TV channel. We should read it from left to right. For example, For example, that1 channel will have 24% in serial, this color, 35% documentary. But if you go into real life production or TV movie, it's really about 0 or 3%. On the other hand, in TV movie genre will be really present ARD and CDF. It means we can see that the distribution is not uniform, and we have a big skew actually even in this genre. If you look a little bit deeper in the data, we can pick up one couple of cases. For example, viewers who watching serial Family Germany, Journal General Science, and fiction movie action. How to understand this graph? It's just like first of all visualization. If you take one point, it's really one viewer who watch together serial Family Germany, General Science, and movie action. We can see that, for example, 20% of time he watched serial Family. Let's say 10% of time General Science, and a little bit movie action. In another chart, we can see a little bit more simple. Some outlet, for example, people who exist exactly 2 people who watch 100% of time only US serial General Family Germany. USA or serial General Family Germany. Or for example, people here, it's exactly 3 people who watch a fiction movie. Now we can try to classify somehow all people together, and to try to get more or less reliable picture how it works. That is why we are using, in this case, for audience segmentation, self-organized map algorithm. It's a couple of words about this sort of algorithms. We can divide on supervised and unsupervised clustering algorithm. In this case, we don't want to define how many clusters we will get. We will just look what we will get at the end. That is why it's interesting sometimes to use unsupervised algorithm. And self-organized map usually looks like a heat maps, 3 or 2-dimensional heat maps, and are made up by nodes. And each nodes, I will go over it in detail just before a couple of words. And each node, we can imagine that's like a one neuron, which have weights, and each weights is some attributes in the data sample. It means we have a data sample in our TV GFK panel about gender, age, which format, which sender, how long viewer watching, and all this data will be mapped to one node, or simple sample of this data will be mapped. The typical, as I said, typical nets, self-organized nets looks like that. It's we just define how big should be organized SOM, and it's also interesting. SOM and 7 One Media is usually also SOM, but it's occasionally. We just define how big is map and how many items could be in one node. This and form of this node. This is one node. After we define this nets, we are running our training process. On this chart we can see a curve which going from up to down, and till this curve still going down, we still continue our iteration process in order to get some better estimation. And we usually stop when curve is to reach this plateau. So about 60 or 70 iteration or epoch, how people also say. A couple of presentation of to get a feeling what kind of self-organized map we get after training. For this purpose, we are using a couple of charts from SOM. For example, node counts. These heat maps show us how many how many samples are in each node. For example, here it will be about 15 or 10 items, and important feature is to see that color going more or less it looks like uniform distribution. It means that color going from blue to dark blue to light blue, and only one node we have like a red or dark red. Could be interpreted like an exception. Another possibility to understand the map is to look at the distance between nodes. We can see that nodes will be grouped in some kind of special cluster, which are defined by color. For example, green nodes and blue nodes should be more or less together. It's the same presentation, but black, white. Sometimes it's easy to understand distribution when we have just a dark color. So now it will be a little bit more funny that we can show what kind of genre is in each node. It's maybe a little bit difficult to see, but actually it's easy to read that we show that we see that the top interview topics show rock, pop, folk, or show food, kitchen represented in each, or often presented in the nodes, and the size of the presentation shows how big is a sample of this genre. In this step, we can already see how we will reduce, or how we reduce dimensional sample to actually two-dimensional visualization, because here we have only x and y axis. On the SOM self-organized map, after that, we can run our classical, for example, Kamin clustering algorithm or hierarchy clustering algorithm to identify nodes which are mostly belong together, to get some kind of reliable picture on our, in this case, TV universe. And we can see that we can put together, for example, top interview fans, or movie fans, the same as the documentary fans, and now we can already identify big groups of viewers who belong together. But before, that's what I want to say again, we didn't define how many clusters we actually get. We are getting this information during our learning process. For typical hierarchy clustering, we are using elbow graphs to define how many clusters we will have, 7, 8, 9. We choose number 7 because it seems to be a good number for clustering, but it could be already a little bit smaller or bigger in this case. Yeah, we use the standard error sum of square for elbow graphs. So now let's look if we get some kind of interpretable results, because of course it's the most important stuff, not only to run some kind of clustering on some kind of funny or a little bit creepy algorithms, and to say, okay, we have a 7 cluster, but what is it? And if it actually makes sense to continue to work with this cluster. Okay, now we can see that the cluster are more or less the same size, only cluster 3 is a little bit bigger. And we will try to put that in our bubble chart diagram to get a first feeling. What is it? On the x-axis we have a age, so from old to young. It means cluster which is here has a 80% young, old, and another percentage young people, and family and old, the same. Family and male, sorry. And when we look inside of this cluster, we can identify that each cluster groups and a couple of features which describe the cluster. Let's look in the cluster, for example, 3. It's the biggest cluster. This cluster has 8.87 million euro with the age, with the main target group structure, with the main age 1429 and 133 viewing time in minutes. And we can see that most of the viewers are in ProSieben, RTL or RTL2 broadcast. The cluster 6, it's also a very interesting cluster. Most of the viewers are on ProSieben or Kabel 1. They're mostly male and in the age 14-29. To try to describe this cluster a little bit better, okay, first of all, we can look in the cluster distribution. We took just ProSieben channel, and we see how the ProSieben channel distribute, I mean people who watch ProSieben, distribute over our 6 cluster. And here we can see that the most cluster where we can find ProSieben is cluster 6 or cluster 3. The same we can see for Z1, and for Z1 it will be cluster 2, cluster 3, so or cluster 0, I mean another cluster. It means we have a good feeling that our clustering will work. To clarify our hypothesis, we can look in the hit list and to watch what the typical title are in the cluster, for example, cluster 0, but we talked all the time about cluster 3 and cluster 8, cluster 6, and in the cluster 3 we can see that mostly RTL channel, okay, a little bit ARD, ZDF because of title. It means in ARD running what's not so typical Eurovision song, or okay, it was a football. And the cluster 6 we can find, as we expected, ProSieben with the Big Bang theory, and yeah, actually it's a Big Bang theory. And in the end, I like to give you one example how it works or how we can use it. For example, in Sunday, we have an amazing Spider-Man on the ProSieben and 96 hours from RTL. 96 hours from RTL. And actually, it's a good question who will get more viewers, ProSieben or RTL. They are more or less on the same cluster, cluster 6, and they try to pick up viewers who are typically watching a program from ProSieben. It's 14-29 age-old males. In this case, we can see that the Amazing Spider-Man is just a more strong format which win and to get viewer in this case compared to 96-hour RTL. And the important is exactly for viewers in this case cluster 6 and cluster 3. And when we take another day, another Sunday exactly, and we can describe or we can take a look into another format, shoots angle ProSieben and Battleship RTL. In this case, we can see that, of course, shoots angle is not a so strong format, and in this case, Battleship from RTL win and get viewers in their own channel. I think it's a last picture. It's our bubble chart diagram. We will put our cluster which we defined and try to describe a little bit this cluster. You can see the cluster 6. It's like we already know. It's a young man, mostly young men community, which are sitcom fans. We have also cluster modern young private broadcast fan. It was a cluster 3. Non-fiction fans, selective spectator. We call that like selective spectator. Well, it was a little bit difficult to create a particular class. I mean, the particular cluster for this viewer. And male public broadcaster and family public broadcaster cluster 1. It's typically ARD, ZDF. Okay, thank you very much, and I hope it was interesting for you to see how it works.